the winter season, right?
Yeah, like 8 degrees.
Very good, very good. I had my sister living in Dallas, and they migrated back to Hyderabad a few years back.
Okay.
They're all well
We have so many Indians here. It's like
gotcha.
Hyderabad.
There you go. There you go. I was about to say that. But that's very good, Ravi. It's very good that you almost have your MS completed there. Your family should be happy and things like that.
Yeah.
And, okay, very good, Ravi. Appreciate that. Let me see what else I got here. So you're in Dallas, you're in MSEE. So you're playing hockey, but you heard everybody playing cricket and IPL. You want to get into IPL, you want to make a lot of money, don't you?
Yes, that's right.
Good, buddy. Very good, Ravi. That's a good introduction. So what I'll do, Ravi, for today, allow me to just shoot maybe 1 or 2 quick questions for you in a friendly way, no pressure. And see if you're able to recall some of our concepts, Ravi. Okay. So let me see. What is your understanding of big data so far, Ravi?
Big data.
No pressure, in a friendly way, whatever you're able to recall.
Presently. I'm sorry.
Okay. How about I give you a hint? Do you happen to remember the 3 V's?
Yeah.
Okay.
Velocity, volume, and variety of data.
Very good. Okay. So can you talk a little bit about any one of the V's, Ravi?
Yeah, today there is a lot of different kinds of data is coming, and there are so many different kind of sources, like main is internet, Facebook, and very high with high speeds.
Very good. As simple as that. So we have exponential volume of data coming in and generated. So that is where the 3 V's are coming from, Ravi. Okay. If you remember, we have fishermen. The fishermen were traditionally going to the rivers, but today all the fishermen can now go to the seas and oceans. And when they go to seas and oceans, they can find more fish. In other words, they are able to get more insights, is what is the thinking, Ravi. Okay?
Okay.
Very good. Okay, Ravi. So allow me to put you back on mute here. And thank you again for your introduction. We'll move ahead here. Thank you, buddy.
Thank you.
Okay, guys. So that is a friendly introduction from Ravi, guys. So that's from for today's introduction. So let's move ahead with today's topics. And I think yesterday we briefly discussed about big data. There was a slide that we stopped at. So let's go ahead and continue our discussion from here, guys. Okay. And let me bring up my tool here. Okay, so this is where we were discussing. I'll skip that one. Let's move ahead to the next one, which is the internal data, guys. Okay. Right now, we're in the process where we are getting familiar with some of the terms and in the world of big data. What is internal data? What is external data? What is batch processing? What is real time? And things like that, guys. Okay. So we'll go ahead and proceed with what is internal data, guys. Okay. Internal data is the reverse. It's like the reverse. This is the data within your organization, guys. Okay. And this is where traditionally all the data, all the companies are going to. Companies are like the fishermen. Okay. So there can be account data, there can be other aggregated data in your data warehouse, and there could be other transaction data in your database and things like that, guys. Okay. In a bank's credit card business, data is generated by multiple processes. So in other words, in a bank, there are many databases. Let me put it like that. And all the data in the database is referred as internal data. Everybody with me, guys? You know, what do they have in their database? They have credit card number, the balance, the name, ID, expiration date, and, you know, what are the transactions that were made and things like that. Everybody with me, guys? Could you give me a quick acknowledgement, please? Cool. Could you just type in a Y, guys, if you're okay with this one? As simple as that. I will not overcomplicate it or oversimplify it, but let's move on to the next one, which is external data. So external data, it is the data which is available with external organizations. Again, if you recall, yesterday we discussed about a credit bureau, a credit card company. Okay. How's others doing on the voice, guys? Is the voice okay? Tushar is saying voice is not clear. How's everybody else doing? Is the voice okay for others? Could you just type in a Y or an N, guys? Okay. So Tushar, just try to see. Manageable. Okay. 90% okay is good. Okay. Let me know if it gets a bit more unbearable and things like that, guys. But I got a new one here, new phone here, and but just keep me posted, guys. Okay. In the meantime, I'll try to make some progress here. And so let's see, credit bureau external data. We were discussing about the banks, they don't maintain the credit history. Many of the customers to a bank go ahead and apply loans and things like that. When a customer applies for loans, what do banks do? Well, they'll go ahead and hook up. They'll hook up with the credit bureau and they say, hey, we're about to give a loan to a particular customer. We want to make sure this guy's a good guy, he has a good credit history and things like that. So the credit history is generally maintained by credit bureaus externally. So that is what is external data. As simple as that. It is data available with external organizations. It can be market research. The data aggregators are the people who collect the data and just maintain it. So in other words, your credit bureaus and, sometimes the social media data is also being collected and maintained by separate companies. They are referred as data aggregators, guys, okay? And there are some companies which do some benchmarking on various kinds of things and they maintain those data. So in such case, we may want to borrow their data, the regulatory authorities and things like that, guys, okay? So credit bureaus aggregate consumer data from creditors, lenders, utilities, and other things from courts to provide an overall view of individual customers' credit performance, okay? That is external data, guys, okay? Everybody be okay with me, guys? Can I move to the next slide, guys? How about that? Cool, okay, all right. So next comes an interesting scenario where we're looking at a data quality horror story. What we will try to understand here is what is called data quality, guys, okay? What happened is, in Great Britain, one day in a popular newspaper, an article got published which ended up being incorrect. Instead of saying 17,000 women, it ended up printing up 70,000 men got pregnant. What happens if that kind of thing gets published in a newspaper, guys? Well, there are going to be a lot of problems and issues that they will come up with and things like that. What happened? The hospital data revealed that these men went to the hospitals for pregnancy-related services and had obstetric exams performed among other prenatal treatments, guys, okay? So instead of actually going ahead and putting women there, it somehow went and picked up their automated software went and picked up men. What is that? That's an example of data quality horror. That's incorrect data. What is that? The quality is not good. What is that? That ends up being a horror story. Is one way to think of it, guys, okay? But what happened? Here's what happened. What happened is, these men had gone to the doctor for the procedural codes that had medical codes close to the medical code for obstetric services. The employees working at the hospital had incorrectly coded the procedures by carelessly entering numbers. So imagine there were a few men who went ahead and they had some, something done at the hospital, okay? So imagine the medical employees who were working there needed to enter something like I01. And what did they do? Well, they entered up something like I01 in there as a medical code. What happened? Instead of picking up men, instead of picking up women for I01, it picked up men. What happens? Well, that's an example of data quality. In other words, that's incorrect data, guys. Okay, what is that? That is called as data quality. The quality of the data is very important. It is not that we have more data available, but what kind of data? Is it genuine data? Is it good data? Is it bad data? Is also very important, guys. The better the data is, the better the quality is. If we don't have good data, or if we have more bad data, we'll end up coming up with horror stories or insights which are not really meaningful or useful, guys. Okay, everybody with me, guys? Am I making sense? Gentlemen, can I move on to the next slide? Cool. So more on data quality. So let's see, what do we do in the world of big data? Well, we try to fix the issues related to the data quality, guys. Okay, what do we do? Well, we may try to figure out, we may have some data and we want to where we have a lot of data, but part of the data is missing. Input process not capturing all the data or not mandating the input process. So somehow we ended up collecting the data. Imagine we went ahead and collected the last 1 year or 2 years of all the tweets from a third-party vendor or from somewhere. What happened? Well, we'd be interested in the text of each tweet, but we have everything else except the textual component of that. What is that? That's an example of missing data. Okay. Junk values. Imagine we were collecting some kind of data, and in the place of age, a survey was done, and in the place of age, they had the name written, names of the people that they were serving was written, guys. What is that? Well, that will end up being called junk values, guys. Okay, because it doesn't really make sense. Now imagine definition, inaccurate or incomplete definition. What is that? Well, imagine you have a field called date of birth, but or age. Let's say you have age, and you have another field called number of years of license you had. Okay, so let me go ahead and say for this one, for inaccurate definition. Oops. So let's come here. Do a little bit of cleanup. Let's go ahead and say there is a form, and imagine age is one field. Another field is, let's say, years of experience. And what is this? Well, imagine for a moment this is the driving license experience. And now what do we mean by inaccurate definition? In the place where we need to put as the age, we have years of experience, or in other words, these two are getting swapped. So what is happening in the survey form? People, when they have to enter the number of years of experience that they had for driving, they're entering the age and vice versa. What is that? That is an example of an inaccurate definition, guys. Okay, or incomplete definition. See that? Years of experience. That is inaccurate. I mean, what do you mean by years of experience? Is that the work experience, or is that the driving experience, right? So that's again an incomplete definition. Multiple definitions could also be possible. So that is again, if we don't have the correct definition, that will affect the quality of the data. If we have junk values, that will affect the quality of the data. If we don't have right data, that is affecting the quality of the data. Completeness. Incomplete data left blank. You were supposed to capture all the age, but the age was not captured somehow. We did not capture it. What is that? That is incomplete data. Validity. Come back to age again. Your age can be anywhere from 1 to maybe 100 or maybe 105, 110 at the most, right? You can't have 1,000. Now, what is that? Valid, invalid data. Again, quality, accuracy. Again, you take the temperature. Temperature is assumed anywhere between 0 and maybe 40 or 45 degrees centigrade. But you go ahead and put 450 degrees centigrade. It's not accurate, right? And timeliness. You are swiping a card and you don't get the response right away, right? That's a kind of a quick example of timeliness. In such case, that will affect. That's again, kind of that may not be very, very precise for the timeliness, but along the lines you can kind of say that is the timeliness, guys. Okay, consistency. What do we mean by consistency? Inconsistent definition across systems. What happens in the world of big data, guys, especially in the world of Hadoop? We are working with 10, 100, 1,000 servers. What is happening? Well, internally, we may have any number of servers. When our request goes to the framework and says, give me my name or give me my age, irrespective of which server it goes to, the request, okay, we should get consistent results. We can't have one, when the first time we ask the Hadoop framework, give me the age of a particular person, just for sake of simplicity. You can say 40. And the same request, if it goes again at a later point of time, you cannot give 41. Okay, so in other words, all the servers need to maintain the data consistently is what it is. Otherwise, again, that will affect the quality of the data, guys. Okay, again, these are some of the perspectives of the qualities of the data, guys. Is that making sense, guys? Everybody with me? Gentlemen, ladies, are you with me? Cool. Okay, let's move ahead. And again comes distributed data complexity, guys. What is distributed data complexity? Well, yesterday, if you remember, come here. Imagine we have assume these are group of servers. For sake of simplicity, let's plug in 5 here. And what happens? Well, assume we have, come here, let's say, that's a big data. Let's say that's about 100 terabytes of data. What did we say? Well, we went ahead and said we're going to split the data into maybe 1 terabyte. We'll put about a terabyte there, put a next terabyte here, okay, and put another terabyte here. Cool, and so on. So imagine you have 100 servers, and what we are doing is we are going ahead and splitting. We somehow wrote a program which splits the data, and then it goes ahead and saves the data into all these servers, guys, okay? What happens? Well, imagine the server goes down. What is that? Well, what happens to your data? Will your data be available or not available? What is that? We need to manually take care of that. We need to write some complex code. That is what is the distributed computing complexity. One aspect of distributed computing, guys. Data consistency. I was just saying, this may be another laptop, guys, okay? So imagine this is a laptop here. And what's happening is there's a user here. He's typing his, his SQL hide commands, pick commands, or HBase commands, and things like that here. What is happening? The request, imagine, goes to the Hadoop framework, which is, installed on this group of servers. But what is happening? The first time the request may go here. The second time the request may go to this server. No matter where the request goes, we need to make sure we're returning consistent data. We can't say this will return one kind of data, this will return another kind of data. That's a slightly complex thing that I'm explaining here, guys. Well, I'll try to explain that, simplify that a little bit in the coming up one. So just bear with me on the data consistency. In short, no matter which request our server goes to, right? We need to get consistent data. Imagine that's your bank balance and your bank is maintaining 100 servers. They need to come back and give you your right balance, irrespective of which request, which server is being handled, is what consistency means. Even synchronization, okay? So what happens when the servers go down? How do you identify? And if you identify, how do you synchronize your data with others? Okay, that is event synchronization. Bandwidth limitations. When we have big data, a lot of data keeps moving from one server to another server. How do you go ahead and deal with that? Well, what is that? Again, that's again another complexity. Partial failures. Sometimes the server can fail. Sometimes a drive on the server will fail. What do you do? How do we handle? What is that? Again, that adds to the complexity. Cascading failures. What is that? A group of servers, imagine, fail. What will happen? That will start impacting the other servers. And that will bring down other servers. What is that? Again, that is called cascading failures, guys. Okay? In other words, short and sweet, what I'm trying to convey here is these are all the complex things that we need to take care of in a world of distributed computing. Okay, what is distributed computing? Well, when you have group of servers and we want to work with those group of servers, what do we need to do? We need to write code which will handle all these things. It's like, again, saying we need to be a mechanical engineer to drive a car. In other words, only when we are able to write code which will take care of all these scenarios, right, we are able to handle distributed computing. And what is the problem? That's complex. Writing code which will this kind of code will be very, very complex, guys. Okay, everybody with me, guys? Or in other words, that is the problem with big data. Gentlemen, ladies, is that making sense, guys? Cool. Shall I move on? Can I move on to the next slide, guys? Cool. Okay, so that's where comes in our hero, which is Hadoop, guys. Okay, what is Hadoop? Well, Hadoop, that's where it comes to our rescue. What does it say? Well, he's a framework. He says it allows distributed computing or distributed processing. In other words, it will take care of distributed storage and distributed processing. It tells us to drive a car, you don't have to be a mechanical engineer. What do? To drive a car, just turn the key. What's happening inside your car? Your petrol is getting converted to electricity, right? But what is happening? It's a framework. What is the framework? A framework is something which does very complex things. Hadoop is the engine. What is it doing? It is telling it will take care of converting the petrol to electricity. In other words, it is taking care of all the complex things that we just discussed. Okay? We just discussed a group of complex, distributed complexity, computing complexities, guys. Okay? When we have a group of servers, apart from the ones that we just discussed, right? What else do we need? Well, here are some more things that we need to add for distributed computing complexity. multi-node communication, multi-process communication, multi-threading communication, networking concepts, okay, and many other concepts we need to understand. What is Hadoop doing? It's a framework. What is it doing? It is manually taking care of all these things. Process, threading, networking, everything, it will take care of us. And what does it do? It allows what is called distributed storage and processing. Okay, so in other words, it allows distributed computing for large data, or in other words, big data. When we have big data, what do? Just turn the key. What happens? Well, you can drive the car. You don't have to be a mechanical engineer. In other words, we don't have to learn all these complex concepts and then come back and deal with big data. That's what Hadoop takes care of, okay? Across clusters of commodity computers, okay? In other words, it uses, cluster means a group of computers. You can have 1 server, 10 server, 100 servers, or 1000 server. Hadoop will take care of the complexities, guys, okay? And it works on commodity computers or servers. What are commodity computers? Well, imagine if you want to go from your work to home or home to work. We don't need to buy a Ferrari. In other words, companies were traditionally using enterprise class servers, which are very expensive, guys, okay? But what Hadoop says is you don't have to use an enterprise class server. You can use what is called commodity servers. They're cheap. They're in the orders of $5,000 from a production standpoint, in a production world. And enterprise class servers start anywhere from $100,000 to $200,000 and so on, guys, okay? So it says you don't need to buy a Ferrari to go from home to work or work to home, okay? And it also allows a simple programming model. What is that simple programming model means? Well, that is the key to your car. What is that? That's your height, that's your pick, that's your scoop, okay? What are they? They're like the batting and the bowling of Hadoop. That is what we use mostly in the world of Hadoop, guys, okay? So again, what is Hadoop? Hadoop is a framework, guys. It is open source, it is free. It takes care of the data management with scale-out storage. What does scale-out storage means? Imagine we have, let's say there is only one server here. So let's come here. Imagine that is one server, and let's imagine we have about, come here. Let's say we have about 1 GB of data sitting here, guys, okay? Now what we're doing is we're doing some processing here. Let's come here, choose this. Let's say we're doing some processing on this 1 GB of data. Cool. And what's happening? Here's what is happening. It's taking, let's say, for sake of simplicity, 10 hours. Okay? Now, I'm going to step back here, guys. We have one server with Hadoop installed. We have 1 GB of data. We're doing some processing. It's taking about 10 hours. Okay? Now, what we do, we take this same 1 GB of data, we put it on, let's say for sake of simplicity, 5 servers or 10 servers for sake of simplicity. So let's say we divided that 1 GB into 10 parts, and let's say, come here. There's the second part, third part, and so on and so on. Okay, now what happens? Whatever was taking 10 hours, right? It will now, if you use 10 servers, it will take 1 hour. What is that? That is called scale-out storage and processing. In other words, as we add the number of servers, not only our processing power increases, but it brings down, it reduces the computation time. What one server takes 10 hours, 10 servers will take 1 hour. Accordingly, if you use only 5 servers, it will take 2 hours. Everybody with me, guys? What is that? That is called scale-out storage. The process of increasing the number of servers. The mantra in the world of Hadoop to increase the performance is add a node, add a server. What is the node? A node is also referred as a server, guys. As we add a server, what happens? Performance increases. What is good about it? Well, we don't need to write code. It is automatically handled by Hadoop, guys. Okay? Is that making sense, guys? Everybody with me? Gentlemen, ladies? Okay, cool, great. Okay, so that's our hero, that's our Hadoop, guys. That's a quick look. And now let's take another look of Hadoop, guys. Okay, pardon me. Among the 10 servers, true streamers, and Hadoop will take care of that. Okay, I will explain you how that works in a minute here. But here is another definition of Hadoop, guys. Okay, we have just now looked at a formal definition. Let's take a look at another friendly definition. What is Hadoop? Hadoop is a group of computers which acts like a single computer. Okay, guys, let me go ahead and select this. put this here. Imagine an apartment building. And for sake of simplicity, let's take 5 apartments. Okay. And imagine, for sake of simplicity, on the top, we have, let's choose this one office. In this one office, what we have, guys, there are no walls in this office. Okay, now what shall we do? Well, let's go down. Let's say select this one. Let's go down. Imagine in the ground floor apartments, all the families are living. And let's say there's a chair in here, in this family. Obviously, if somebody comes into this apartment, they cannot see their chair, right? Because there are walls there. Okay, but imagine we go ahead and put the chair in the first floor. And what do? Well, imagine, for sake of simplicity, whether we come from this one, whether we come from this one, or from this one. If we enter the first floor, we're able to see the chair from anywhere in your office. Why? Because there are no walls. We can see everything. In other words, your first floor is really a group of apartments, but it's acting like a single apartment. It's like a single office. Keep that in mind for a moment. What is Hadoop? Hadoop is a distributed file system. What is a distributed file system? A distributed file system is a group of computers that act like a single computer. What does that mean? Well, again, come back here. Let's come here. Let's choose this one. For sake of simplicity, imagine we have a file which is sitting on this server. Okay, now let's come here. Let's say we logged into this server. We logged into this server and we try to read that file. We cannot read it, right? Because, from one computer, you just cannot read the data on the other computers and servers. That will be, a security risk and, things like that, right? So what happens? Well, that is what is a local file system. But what does Hadoop do? It makes all these 10 computers like a single computer. In other words, let's come here and see. We'll go ahead and add a layer here on top of it. And now, let's say for sake of simplicity, we take a file here. We take a single file. We store it in HDFS in Hadoop. What do we do next? Well, let's say for sake of simplicity, whether we log in from this server or this server, let's say we access Hadoop, which is our distributed file system. What can we do? We're able to read that. In other words, pardon me, sorry about the pause, guys. Just give me 1 second here. Okay, so in other words, no matter from which computer we go ahead and add a server, add some data, we will be able to read it from HDFS, guys. Okay, so let me see if I can simplify it a little bit more and clean this up a little. Okay, so first definition, distributed file system. What is it? It's a group of computers. They act like they're single computer, guys. Okay, then think of that as our apartment building. So HDFS is like your first office. Okay, first floor, office in the first floor. So if you have a chair, no matter in which apartment you enter, if you enter the first floor or if you enter the HDFS, we'll be able to read the files as if it's a single computer, is what we can say. And let's see, here is another way of looking at it, guys. Okay, imagine we have one server. There are about 4 IO channels, that means 4 hard drives, and imagine we are able to read at a speed of 100 megabytes per second. That's the speed at which we are able to read the data. And what do we need to do? Well, imagine for sake of simplicity, we need to read about 1 terabyte of data. And what do we have? Well, we have installed Hadoop. Okay, so what happens? Here's what happens. It may end up taking 43 minutes at that speed. But in the world of Hadoop, if we add more machines, the same thing can now be done in 4.3 minutes. What is that? Well, that is the mantra of Hadoop. As we add more servers, our processing power is increasing. Our processing time is decreasing. What is that? That is the mantra of Hadoop, guys. Okay, it's also called as horizontal scalability. Okay, one more time. What is Hadoop, guys? Hadoop is a distributed file system. What is a distributed file system? A group of computers. They're acting like a single computer. when this group of computers, they can be 10, they can be 100, they can be 1000, okay? They act like a single computer. So what happens is there may be a file here. I may be logged in here. I will be actually be able to read that. How? That is, logically what is happening is it's acting like a first floor. And if I put a file in this computer on this server, that is actually going and sitting in the first floor. So that's why we're able to access it, guys, okay? And another important point is, as we add more servers, what happens? The performance increases, the processing power increases, the processing time reduces. Everybody with me, guys? Is that making sense, gentlemen? Cool. Gentlemen, ladies? Cool. Okay. So now let's see how Hadoop works, guys, okay? For sake of simplicity, let's go and blank this. And I will just give a brief this thing here. Imagine this is your laptop. And what do we have? Well, for sake of simplicity, let's say we have about, come here, 100 MB of data. Okay, what did we do? Well, we go ahead and load it into our laptop. Okay, or in other words, we have 1 GB, 100 MB of data here, guys. Okay, so let's go ahead and say, come here. That's about, for sake of simplicity, 100 megabytes of data is what we say. Then what do we do? Well, imagine, for sake of simplicity, we have a group of servers here. Cool. So let's come here. So let's say that is server 1, server 2, that is server 3, 4, and 5. For sake of simplicity, we have only 5 servers. And what is that? Well, we have Hadoop installed on all of them. So what happens? Well, then now Hadoop, what is Hadoop, guys? This group of computers act like a single computer. So what happens is we want to go ahead and, let's say, load this into this Hadoop framework, into this distributed file system. So what will we do? Well, we'll write a simple Linux command. Okay. What will Hadoop do? Here's what Hadoop will do, guys. Okay. Imagine it's going to take our data. It will automatically take that 100 MB file. It will break it into a 64 MB as one part. Then it will break it into a 36 MB. Okay. What is that? It will call that as block A and block B. Cool. So let's go and say this is, let's call this blue, right? Let's come here. See this for a minute. So that is block B. And come here. This is block A. It calls this, splits as block A and block B, guys. Okay. Okay. That is the first step. What is it doing? It is splitting your data. Splitting. Oops. Come here. It's splitting your data, your 100 MB in the orders of 64 MB. So 64 plus 36. Next, what will it do? It will go ahead and take this block A, save it to one server. It will take this block B, save it to, oops. One second. Save it in another server. What is that? It is saving the data. It is saving your block into different servers. This is called distribution. It is distributing the data, guys. Okay. Next, what will it do? Behind the scenes, it will also go ahead and make a backup. So come here. Come here. It is going to make a backup of block A here. It is going to make another backup of block A. Similarly, come here. It will make a backup of block B here and another backup of block B here, guys. What is that? This is called replicating. What is Hadoop doing? Hadoop is doing what is called SDR. Come here, SDR. Split, distribute, and replicate, guys. Okay. Why is it replicating the data? Well, it works on what is called cheap servers. The cheap servers, the problem with the cheap servers is they can fail anytime. Enterprise class servers don't fail that often, whereas cheap servers can go down. So if cheap servers fail, what can happen if we don't have the replica? Well, we are at a loss of block A. So to avoid that, we go ahead and Hadoop internally goes ahead and maintains backup. And when this is going on, what is happening is, well, here are some of the important things happening. What's happening? Multiple servers are communicating with each other. Multiple processes are communicating with each other. Multiple threads are communicating with each other. Networking concepts are being automatically handled. All the distributed complexities are automatically handled. By whom? By Hadoop. What does that mean? Well, we don't have to be a mechanical engineer to drive a car. What is this? This is called distributed storage. Our data is getting distributed and stored in a group of servers. That is what is called distributed storage, guys. Everybody with me, guys? Am I making sense? Gentlemen, ladies? Cool. Okay, so that is one perspective of it, guys. That is what we are doing. No matter what you give Hadoop, if you give any data, what we have seen is for 100 MB data. Let's say you give 100 terabytes of data. What will you do? Its first step is split the data into pieces. Step 2, it will go after it splits the data, it will go ahead and call each split as a block. So let's come here. So come here. So that is the data. Imagine, for sake of simplicity, this is a 256 MB file. Okay, so that is 64 MB, block 1. This is another 64 MB, another 64 MB, another 64 MB. We can tell Hadoop to split in the orders of 128 MB, 256 MB, and things like that. And that is configurable. We'll talk about those configuration settings later, guys. Okay, so the first step is splitting. The second step is it is distributing it. One block there, another block there, another block there, and so on. But what is the problem? The problem is the servers can fail. Why? They're commodity servers, guys. Okay, and what happens? That's the reason why Hadoop goes ahead and replicates data. Why? If one of the server goes down, we still have backup available. What is that? We're protecting the data. In other words, that is also called as data fault tolerance, and it is protecting the data. Who? The Hadoop framework. Okay, so what is all this? Well, these are some of the things that the developers or programmers were manually writing code. Okay, and what is Hadoop doing? Hadoop is automatically taking care. You want to drive a car? Turn the key. Don't worry about. We don't have to be a mechanical engineer, guys. Hadoop is taking care of splitting it, distributing it, replicating it, and above all, it also allows us to write what is called scale-free programs, guys. Okay, so what is the scale-free program? Scale-free program is, imagine we have only one server. Come here, let's cancel that. Okay, imagine we have only one server, and let's say we have a small file which is sitting there, and what's happening? There is some processing happening. Let's come here. We have written a small hive or a pig script, and we are doing some analysis of data and things like that. So what is happening? Well, now let us say this is only one. Oops. This is only 1 GB of data. Okay. So what happens is, imagine tomorrow our data increased from 1 GB to, let's say, 100 terabytes. What happens? Well, the beauty is we don't need to make even a single code change. Okay, what works on 1 GB of data will also work on 100 terabytes of data. What is that? That is called scale-free programming. Why is that important? Well, that's a very, very complex thing, guys. Okay, if developers manually have to write a program or develop a program which will go ahead and work independent, which works on independent of the size of the data, what will happen? It becomes very, very complex. What is Hadoop doing? Hadoop is again taking care of that. It allows us to write what is called scale-free programs. In other words, your code or our code is independent of the size of the data. That is what is called scale-free program, guys. Okay, everybody with me, guys? Everybody understand that point, guys? So Srujan, we can go ahead and configure our block size to be 64 MB, 128, 256, or anything. We'll talk about those configuration settings in the coming up sessions. But that is generally the admins. In the older versions, or when Hadoop 1.0 was released, 64 MB was the default block size. Today in Hadoop 2.0, they made 128 MB as the default block size, but the concept is the same, whether it is 64 MB or 128 MB. Everybody with me, guys? Is that making sense, gentlemen? Will the data size affect the clusters? Absolutely. Data size, or rather Srinivas, size of the data is a fundamental aspect of your cluster. Size of your cluster. You design your cluster based on the estimated size of the data that you're dealing with, based on your volume of the data that you deal with. Okay, or in other words, short answer is just Srinivas. Okay, guys, everybody with me? Can I move on to the next slide, guys? If the volume is increasing rapidly, you have to increase your number of nodes. Okay, another good question from Srinivas, guys. Okay, so he's asking what happens if the volume suddenly increases. What do? Well, you can, without bringing down your entire application, we can go ahead and add nodes. Okay, we don't have to bring down our application, guys. Okay, that is what is important. So another important concept, guys. Okay, let's try to. So Srinivas, let me know. Okay, you're cool. Okay, great. Okay, so another important concept about replication, guys. Okay, let's see what we have here. Imagine this is your laptop, and in your laptop we have a file which is 150 MB. Okay, and let's say we have decided to load this into Hadoop. What is Hadoop? Well, again, I'll say this is a group of computers, and this group of computers are acting like a single computer, and that is what is distributed file system. Okay, what is a rack? Well, for those of you who are not really familiar with rack and things like that, yes, it's just a physical enclosure, a physical box in which you can plug in server 1, server 2, server 3, server 4, like that. You can plug in. And what is a rack? A rack is a group of servers. A group of racks is called a cluster. As simple as that. A cluster is nothing but your Hadoop distributed file system, guys. Okay. And what do we want to imagine? We have about a file about 150 megabytes. And what do? We have decided we want to load this into our distributed file system. So what will happen? Well, here's what is about to happen, guys. Okay. So first step, it will go ahead and split your data into block A, block B, block C. That's 64, 64, and 22. We'll keep it simple and assume that is 64, 64, and 22, guys. Okay, so that's 150 MB. Second step, it is going ahead and saving it in one rack. What is that? That is block A. Next step, it is going to replicate the data in another rack. Okay, so as it goes ahead and saves, distributes this here, it's good and making a copy of this in the second rack and another copy of it in the same rack. It is not making a copy of it here, another copy of it here. It will always maintain a copy of the data in another separate rack. As a couple of copies are maintained in one rack, another one is maintained in another rack. The reason is, if this rack fails, we can still retrieve our blocks of data from here. The same principle holds good for the rest of the blocks. Oops, I think I have the green one missing here. But imagine, come here, let's select the green one here. Let's say that's the green, it's replicated here, and it's replicated here. So if I have this rack failing, oops, come here. So if we have, for some reason, this rack failing, what can we do? We have all the copies available in the two racks. If we have this rack failing, okay, sometimes things like that will happen. We can still retrieve all the three blocks from these two, and the same principle applies even if this rack fails also, guys. Okay, what is that? That is how the data is replicated within Hadoop, guys. Okay, here one thing you guys need to remember is, what is rack? A group of servers in a single box, in a single physical enclosure is referred as rack, and a group of racks is called a cluster. That is what you want to keep in mind, guys. Okay, that's a couple of points. Another couple of points is, it saves one copy here, another two copies are saved in another rack. What is that? That is called rack awareness. We'll talk about that in the coming up sessions, guys. Okay. Is it necessary to have two backups? By default, that is what is suggested. By default, Hadoop saves 3, but it is not necessary. Short answer. We can also configure that. We can also configure it to 2, 4, or more than that also. 2 and 3 is being on the same rack. The replicated block 2 and 3 replicated is block 2, data node 3, block 2, data node 3. Okay, Srinivas, rephrase your question. I'm not understanding your question. Okay, let's unmute Srinivas, guys. 1 second here. Okay, Srinivas, go ahead, buddy.
Yeah, hi.
Hey.
So my question is, we have replication factor of 3, right?
Mm-hmm.
So we have 3 blocks.
Mm-hmm.
So I've been seeing the second and third block is on only one rack. For example, block A has the copies of 2 was on the second rack, fifth and sixth server. So, and also the block B has the remaining 2 racks on same server, rack 3. Similarly, the block C is also having the remaining 2 on one rack, rack 1. So, is there any like the remaining 2 should be on the same rack?
True.
For example, if 2 racks are down because we won't be having the data.
That is true. If 2 racks are down, then you have some serious problem with your cluster. You definitely need to have your admins look at that and have them take care of that personally and manually. Would be a short answer. And yeah, data will be unavailable in such a case.
Okay, so why the same, like the replication was not on like 3 different tracks?
Okay, so in other words, imagine again, let me go ahead and imagine you didn't have this one here, and imagine you didn't have this one here, but let's come here, choose this one. We had the red block replicated here, red block replicated here. And imagine.
No, let me go in this way. Like rack 1 block, rack 2 1 block, rack 3 1 block. So there is no problem of data unavailability.
You can do that, but if you want to go do that is over optimization. So in other words, Hadoop is already optimized to go ahead and take care of the data protection and the fault tolerance. But if you want, you can also go ahead and make some code change to the rack awareness script. We'll talk about that rack awareness in the later sessions. You can also maintain it like that if you want it. But you just need to touch code, and that is too much of optimization, or rather, people generally don't have to go that far. It's another way of looking at it.
Okay.
Good question, Srinivas. Thank you, buddy. Is that it?
Thank you. Yeah. Thank you so much.
Thank you, Srinivas. Okay, guys. So that is Srinivas. Good question. And that is what we need to keep in mind in this one, guys, and what is called our replication. Let's do a little bit of cleanup here. Okay, now next comes what is called data locality, guys. Okay, so imagine, for sake of simplicity, our data is stored here. Let's go and also plug this in here, plug this in here. These are the copies of our green block. Now imagine, this is our laptop. Cool. For sake of simplicity, that's our laptop. What are we doing? Well, imagine, again, for sake of simplicity, we're writing some code in Hive, Pig, or Java MapReduce program. Okay. So what will happen? Well, here's what is about to happen. For sake of simplicity, if we write in Hive or Pig, the code is generated. When the code is generated, guys, what will happen is your code will be shipped or deployed to this server from your laptop, one, and it will also be deployed to this server. Imagine it is also getting deployed to this server. What will happen? Well, your code is now getting run, or your computation is happening in parallel in 3 different servers at one time. What is happening here? It is the code which is being shipped or deployed to different servers by the Hadoop framework. It is again taking care of converting the petrol to electricity, guys. We don't do that. We just write Hive script and we just say enter. That's when the code is getting generated and getting shipped here. What is it? Well, that is what is called data locality. It is called taking the processing to the data. And why is that important? The reason that is important, guys, is traditionally, this is how things used to work in traditional. You will have a database, then we will have what is called, okay, I may have explained this one maybe yesterday, but just bear with me. We will have what is called data access layer, then we'll have what is called business layer, then we'll have what is called a service layer, then we may have what is called a let's say, how about this one back here, a UI layer, and this is where our end users are. Cool. So that's where our end users are, guys. What happens is, traditionally, the data is here. We write some stored procedures. We filter the data. Data is sent here to this server. The code is sitting there. Some data objects are being built here. Then the data objects sent. So each box is one server. So let's go ahead and say this is data access layer. Then you have your business layer here. This is where the business rules are applied. Then the code is sent from business logic layer to service layer, where your authentication and authorizations are done. Then your data is further sent to the UI layer, which is here, which is your browser or maybe a Windows application and things like that. So what's happening here? In traditional architectures, it is the data which is moving from one server to another server to another server and finally given to the end user, guys. Okay, so the code is sitting in the boxes. What is happening? Where in traditional architectures, data is moving and code is sitting. What is happening in the world of Hadoop? It is the code which is getting deployed or moved. Oops, pardon me. It is automatically being deployed or shipped to different servers. Okay, why? Another important reason is, imagine in the world of big data, come here. If this is the size of the code, our size of the data, because we deal with what is called big data, is that much. In other words, if we, like in traditional architectures, if this is the code, this is the size of the data, guys. If we move the data, if we move this amount of data from one server to another server and things like that, and imagine that's about 100 terabytes of data moving from one server to another server, number one, it will not fit. Number two, what will happen is it will take too much of bandwidth. It will slow down the entire cluster and very, very few things will work. What have they done? They have intelligently replaced that. Let's see if I can, oops, I can move this. There you go. If we move the code from one server to another server, it will take less bandwidth. We can run multiple jobs at one time. The performance will be faster and many other advantages will be there. What is that? That is what is said as the code. The data sits wherever it is, but it is the code which is moving around the servers. What is that? That is called data locality. Data is local. It is the processing. It is the computation of the code which is moving from one place to another place in the servers, guys. Okay, and what happens? The processing happens in parallel. The parallelization is another complex thing. Complexity in distributed computing, which is automatically taken care or handled by Hadoop framework, guys. Okay, am I making sense, guys? Gentlemen, ladies, is that making sense? Cool. Okay, so that is one look of it. We'll also discuss more about data locality in the coming up ones, guys. But let me see. So more from a developer standpoint. Why Hadoop? Well, here are a few reasons, guys. Okay, it is accessible. In other words, it runs on large clusters of commodity servers or on cloud also. We don't have to write some complex code. It is robust. That means if any of the servers fail, it can handle them gracefully. It is designed, it is architected with the assumption of frequent hardware malfunctions and can gracefully handle it. It is scalable. The more the servers we add, what happens? The more the performance we get. That is the mantra. In other words, pardon me. The more these servers we add, our processing power increases, or computation time decreases, guys. Okay, and the larger the data scales linearly. By linearly means if one server is taking 10 hours, you put in 10 servers. There's a linear ratio in which our performance is increasing, right? That is what we mean by linearly, guys. It scales linearly, is what it means. Okay, it is simple. We don't have to worry about many complex things. To drive a car, you don't have to be a mechanical engineer. Okay, what do? We write simple SQL-like commands using Hive, simple English-like scripting statements using Pig, and it will go ahead and analyze the data in a simple way, using Pig and Hive, guys. Okay, data locality, the concept which is inbuilt. It is one of the fundamental design principles. What happens? It is the code which is moving to the data. The data moves only when we are loading the data. After that, the data is always sitting there. After that, it is the code which moves to the different parts of the data. How does that work? Well, we'll talk about that when we cover the MapReduce, guys. Okay, what are we saying? Since data is sitting, code is moving, we say data is local, or that principle is referred as data locality. What is Hadoop doing? Hadoop is also replicating the data. Why? Because it deals with cheap servers which are unreliable. What are all these things? Well, these are all the characteristics of Hadoop. Why are they important? Developers were manually writing code. They were first becoming the mechanical engineers to drive a car. Everybody with me, guys? Am I making sense? Cool, gentlemen. Okay. And here is another quick look from a company, from a financial or from a company standpoint. Why companies should adopt Hadoop? Well, business drivers. Bigger the data, higher the value. The more the data they have, the more the value they get out of it, guys. Okay, and that's a very, very important thing. So today, everybody wants to get more data. Yesterday we looked at an example where we looked at a lady, a female, and when we traditionally look at her data in the database, we assume, hey, she's a female, she's in this age range, this is her salary. That's all we need. But when we actually go and look on the maybe something like social networking sites and things like that, there were many insights that we were getting out of it. We understood that she likes to travel. She's subscribed to a fashion magazine, and her spend capacity is maybe $400 for subscription and things like that. What is all this? Well, that is only one person. What is happening today? If that is the information, that is the insights we're able to get for one person, and what's happening? There are millions and millions of people on the internet. We can try to understand insights of such kind for millions of people. And what do companies do when they understand these things as well? They'll be able to make more business. That is what we mean by bigger the data, higher the value. Is that making sense, guys? Do you understand that point, guys? You can feel free to type in an N also, in case you're not following me or in case you don't agree with me and things like that, guys. Okay? Feel free to let me know. But is that making sense, gentlemen, ladies? Could you type in a Y, guys? You understand, bigger the data, higher the value? Cool. Okay, great. Okay. So let's see. Financial drivers. We don't need a Ferrari car to go from our work to home or home to work. In other words, we can use cheap servers. As a result of that, the cost per terabyte comes down. That's not a financial advantage for the companies. That's why it's good to use Hadoop. That's one of the drivers. The technical drivers, what's happening in the traditional architectures as the data is growing, as the 3 V's are increasing, the traditional architectures are failing. The more the data they have, they are failing, guys. Okay. So what they do is, if they have last 5 or 10 years of data, they will just say maybe last 1 or 2 years of data, and they will do their analytics on that. And what is happening? Well, the lesser the data, the lesser the value. What happens? Well, that is what this one is. If they're somehow able to process all the data that they have, they get the higher the value. And traditional architectures are failing. That's another reason why companies are adopting Hadoop, guys. Okay. Everybody okay with this slide, guys? Gentlemen, ladies, are you okay with this? Cool. Okay. Okay, slightly heavyweight. What I'll do is, for today, I will go ahead and wrap it up here, guys, and we'll continue from this slide tomorrow, guys. Okay. And let me. Okay. For today, let's see where we are. Almost at 9:05, about now there, and slowly we'll try to increase our time and things like that. And we'll continue, guys. Any other questions, guys, for today? I'll give you a minute here. If any of you want to come on here real quick and maybe in the chat, okay, we'll do that. Hold on 1 second. Let me try to find that. Come here. Python, right? Is that the one? Spic. Okay, this is for Sparta. This is this one. No, that one. I think this is one, guys. Yeah, this is one. So you want me to share this one? Send file. Okay. So let me see where this is. Spark. I have not. This is actually another one, guys. I can't really. This is complete Spark. So what I'll do is I'll go ahead and delete this one. I will later add touch of Spark to that, guys. I haven't finalized it. So let me to just remove that one. MAIT. This is only Hadoop tab. Say version 3. 7. There. Cool. And now I need to do a send file. And it's probably here. Send NIT. Root of NIT. Right. So let's select that one. This file is enter name. Oh, okay. Close them. Cool. There you go. To everyone. Sequence in which you cover however we access. So let me just go there. Open this one. So what I'm going to be doing is I will understand the Hadoop cluster architecture. The next we will go on to MapReduce. Probably the only thing that I will be interchanging a little bit is advanced MapReduce and Hadoop. This one and this one I will cover after Hive. Advanced MapReduce and Yarn I will cover after Hive, guys. Okay, and that's the only thing I will change from a sequence standpoint. What is your other question? Recorded sessions. So I think Srijan, what they will do is I think they will just in a day or two they will verify if you have completed your formalities like paying the fees and things like that. They will start giving you the access to the recorded sessions, Srijan. I think they put it on a G drive or something like that, so that you can go ahead and access it from the G drive, and that is the process. Srijan. Okay, am I answering your question, Srijan? Okay, great. So prerequisites to learn Hadoop. Again, you don't have to be a Java developer. That is the common question. If you have about 10 developers, not all 10 developers are generally the Java developers, guys. There are only 2 or 3 of them who are Java developers with Hadoop. The rest of them are they don't really need to have any Java, is my real world observation. And if you're slightly familiar with SQL, that is okay, but it is not a must, Sahil. Okay, we'll get into Hive and I'll kind of teach you right from the basics only, and that should be of help to you. Cool. Okay, thank you, Sahil. Thank you, Srijan. We need to be in MapReduce. You leave that to me. I'll make you good in MapReduce, Srinivas. Okay, MapReduce, you need to have an understanding of that. You don't have to be an expert in that, and I'll try to simplify it so that you get a good understanding of that, and hopefully you'll find it much easier. But again, for Pig and Hive, you don't have to be expert in MapReduce. You don't even need to worry about MapReduce, to be frank. Okay, even from an interview standpoint, if you have an idea of MapReduce, that is enough. Only when it is an advanced MapReduce, when you have tried some advanced Java MapReduce programs, when Pig and Hive, 70 to 80% of it is generally handled by Pig and Hive, guys. Okay. And something that Pig and Hive cannot handle, that's when we will actually go and look and use Java MapReduce. But that is, generally handled by the Java folks, guys. Okay. Yeah, you don't need to worry about Java and MapReduce. You leave that complexity to me, Srijan. I'll try to simplify, and we'll do some complex exercises here, and you'll be able to get a feel of that. Okay. Cool. Okay. Okay, guys. So for today, allow me to wrap up here, and I'll look forward to meeting you tomorrow. We'll regroup again tomorrow, and we'll take it from there, guys. Okay. Kids, say a final goodbye. It's okay. Can you point what kind of concepts you need to brush up in Java? Just code Java, a little bit of touch of object-oriented concepts, Srinivas. Oops. If you're aware, that's it. You don't need to worry about anything else. As simple as that, Srinivas. And again, Java is not a must, Abhinav. If you don't have Java, don't worry too much. Hive and Pig is our batting and bowling in a game called Cricket or Hadoop, and that is what you mostly use. And cool. Okay, great. Thank you, guys. I appreciate that. You guys take care, and I'll look forward to meeting you tomorrow, and we'll go from there. Thank you again. Bye for now, guys.